In this session, we shall be discussing the absolute change, the fractional change, and the percentage changes in values as they happen. So let's start. Now, if we refer to the table includes 9 different things that we have included here. You would see that all these 9 things would talk about the changes. So there are 3. The first 3 talk about the changes in value. Now, when we say changes in value, that could be any value. Value here refers to any unit. That could be rupees, dollar, kilometer, hour, etc. The next 3 things which we are talking about from point number 4 to point number 6, we are talking about changes in the fractional value. So when we say, so instead of saying value now, we are saying increase in fraction, no change in fraction, a decrease in fraction. And the final 3 points, which is point number 7 to point number 9, we are talking about changes in percentages. So when we are referring to changes in percentages, then we will see what are we doing. Now, the next thing which is important here is, which is a part of the basics, is you would see that any change requires 2 entities. For example, if I would refer to the 5 columns and excluding the column for enumeration and the cases that we are discussing, we will see that there are 3 broad columns that we are talking about. One is the change, which is the change in value. Then the next one is the original value, and the final one is the final value. So for a change in value to happen, the remaining 2 values should be known to us. Going further, going to the next level, out of these 3 values, which is CV, OV and FV, exactly 2 values should be known to us to find out the third value. Incidentally, here we are interested in finding out the final value. But before we do that, let us formulate the basics, or let us formulate the concepts that we are going to discuss. So now you would see that now in the entire session we'll be talking about the acronym form of change in value, original value, and FV as the final value as CV, OV and FV. These are the acronyms that we are going to use. Okay. Now, can I say that the change in value, which is CV, is equal to the final value minus the original value? So what I intend to say here is, any change would be observed only when or over something that would have happened first. So for example, let a thing happen first. So the first thing which happens here is the original value, and thereafter any other happening will be taken as either the final value or an interim final value. So now we are only talking about a single change. So single change means when we have one change, and one change is signified by one final value minus one original value. That is what we are going to talk about. So change in value would always be the final value minus the original value. Let's now treat this as a formula. From here, we'll be able to say that the final value will always be equal to the change in value plus the original value. Right? So you can make a formula out of this, the one that I have put inside a box. You can treat this as a formula now, and this formula comes out of the basics or the concept that I have discussed in the last few minutes. Now, The second point which arises here is, now when we talk about a change to happen, here incidentally we are talking about the change in value. So the changes could happen in three ways. One is no change at all, which we can signify with a zero, which we can represent with a zero. No change happening is also a change. And the other one is the change which is happening, which is positive, which means increase, and a change which is happening is negative, which means decrease. Synonymously, you can use some symbols like this, which is arrow upward for increase. Zero can be written as such, and a downward arrow for decrease. These are some synonymous representations that you could do for various changes. Please make a note of these changes. There cannot be a fourth change here. There will always be three changes only, which is why you would see then when we are talking about these cases, so we are talking about 3 into 3 cases, which is 9 cases altogether. Now, moving on to the next stage. Now, before I move on to the next stage, let us, whatever we have learned, we here refers to learners, whatever we have learned here, let us try and practice it as well. So now when I'm looking in for final value in the first case, and I know that the final value is the original value plus the change in value, and in the first case the change is positive, can I just fill this box as this will be rupees 100 plus 110? 100 plus 10, which makes it 110. Synonymously, now here the original value remains the same as 100 rupees. And since there is no change that has happened, the final value would be original value, which is 100 rupees plus rupees 0, which is again 100 rupees. In the third case, there is a decrease in terms of the change in value. So which will be 100 minus 10, which makes it 90 rupees. Now once we have done this, now let's move on to the changes in fraction. So now when we are saying change in value, so that is already done. So now change in value for a fraction. Let me represent it in the form of CV for a fraction. This is one way in which I could write this, or I could write it as, it is all dependent on you. As long as you understand the concept, you can make your own definitions. So here we are saying fractional change in value. So either I write it like this or I write it like this, does not make any difference as long as I know the concept. But for a fraction, we know that a fraction comes into existence only when we talk about the numerator and the denominator both. Both of them coexist in a fraction. So in that case, the first concept that we had discussed, let me just put it as #1. And #1 here refers to the concept that we had discussed, the first concept. And let me put the fractional change concept as #2. This is for fractional change. So we know that for a fraction, the denominator should exist. And when I say denominator, I am basically referring to what? Referring to the base. So let me say, now when I am writing a fraction is represented by a numerator n upon a denominator. Now let me combine it with the discussion that I have already had with you. So now when I say denominator is the base, so in the denominator you need to take the base value. So base value becomes your original value, and the numerator would be seen representing the final value, which you can relate once you take your learnings to the next level. Okay, so now let us see in the first case, how can we convert this first into FV upon OV. So let me write it down. We know that FV is equal to CV plus OV. Now if we divide both the sides with OV, can we say that FV upon OV, which is the final value upon the original value, becomes equal to 1 plus CV? Upon OV. Okay. I hope you are able to understand this formula. And here I have explained it and we have derived it. So when you are learning something, please try and derive the formulas first, because that is something which gives you greater insights on the topic that you are dealing with. And once you have had greater insights, then it becomes easier for you to practice them in terms of not trying to mug up the formulas, because the formulas or the concepts, they become very handy to you, and in that case they come out naturally. So finally, now I know that there are three cases, the three cases that we already talked about in terms of the change in value. So can I put it like this now, that FV upon OV will be either I am supposed to add something, add a fraction to it, subtract a fraction to it. In case if there is a negative change, then there would be a fractional decrease, and then I am supposed to write down the fraction. What is a fraction? The changed fraction. So let me put it as, instead of putting this, let me put a square bracket here, and then inside this I could say the fractional change in value. Now when we are referring to the fractional change, what do we intend to convey here is, we are saying that 1 plus if there has been an increase, or 1 minus if there has been a decrease. You have to be judicious enough to apply it accordingly. So this becomes your formula. Please make a note of this. Now let us fill up the boxes here. And here what I am doing is, I am using the values that I had taken up originally. So which values am I taking here? The original value in all these 9 cases would be ₹100, and the change in value would be either plus ₹10 or minus ₹10 or 0 rupees is what we are using. Right? So these are the values which are going to remain common for all these 9 cases that we are going to discuss, out of which 3 cases have been already discussed. Now in this 4th case, when we talk about an increase in fraction, that means I am basically talking about the fractional increase. So when we are talking about the fractional increase, and you know that you have increased ₹10 over ₹100, in that case what is going to be the fractional change in value? The fractional change in value that we had already highlighted in this case becomes plus 10 by 100, which can be eventually written as plus 1 by 10. Now if somebody says that there is a fractional increase of plus 1 by 10, it goes without saying that there has been an increase over the original fraction, and in this case the original fraction is 1. Now 1 is treated as, if I say 1 divided by 1 is just like saying that the final value of a fraction is also 1 and the original value also is 1, which is just like saying no increase or no decrease. So now in this case, when we say what was the original value, in case of a fraction, we'll take the original value as 1, and the fractional increase has been 1 by 10. So this becomes 1 plus 1 by 10, which becomes 11 by 10. Now, when there has been no change in fractional value, in that case, the original fraction still remains as 1. And when there is no change, we would say this is 1 plus rupees 0 by rupees 100, which is 1 plus 0. In that case, the final value becomes 1. Third case, the original value in any case was 1. And from here we are subtracting 1 by 10, which becomes 9 by 10. Now, once we are able to find out the fractional change, you would see that you will come across 3 different types of fractions. One is 11 by 10, to which we call it as an improper fraction. The other fraction is 1, which we call it as an ideal fraction. And the final fraction that we got here is 9 by 10, to which we call it as a proper fraction. And then you can take your learnings to a next level, which says that if I'm getting a final value in terms of a fraction, final fractional value, if I'm getting, because when I'm talking about a fraction, the word value will not simply have a value, it becomes fractional value. So original fractional value is 1. The final fractional value, if it comes out to be an improper fraction, see the converse of what we have done. So if somebody tells you that the final fractional value is 11 by 10, that means you would have added some fraction to the original fractional value, which was 1, which means increase, profit. If the final fractional value was 1, that means no increase, no decrease. And if the final fractional value is 9 by 10, to that we call it as, we already know that it is a proper fraction. In that case, it symbolizes a decrease, loss, or a discount. The final concept. So the final concept here is, now when we are talking about percentages. So when we are talking about percentages, now it becomes so easy. You would see that all these 3 concepts are interconnected. And the one which requires the most clarity out of these 3 concepts is the first one, because based on that only we were able to find out the second concept. Based on the second concept, we are going to find out the third one, which is, so can I say the percentage change or anything? When we talk about the final value upon original value, now we will talk about the final percentage, original percentage, and the change in percentage, because the terminology of the discussion also changes now, as discussed earlier. So when we're talking about fractions, then we talk about original fractional value, final fractional value, change in the fractional value, right? So now when we are talking about percentages, instead of value, we'll be putting it as percentages. So final percentage, let me represent it first. So either we'll say change in value for percentages, or we can simply put it as percentage change in value, or we can also say change in percentage. Now this CP does not mean cost price. Here P represents change in percentage, or we can say percentage change in value, because if somebody gives you the value and then they are asking for what is the percentage change in value, so in that case we will judiciously use those units or use those terms. So now in this case, what I can do here is I can take the original value as 100% in all the 3 cases. Now 100% means what? It is your base percentage. Base percentage means what? No increase, no decrease. No profit, no loss. No increment, no decrement. So now in this case, let us do it judiciously now, and you would see that the fractional change in value and the percentage change in values, they go hand in hand, except for the units that we are using here. So here in this case, we can say this is 110%. In this case, in the 8th case, we can say this is 100% plus 0%, which is the fraction, let's say the final percentage change in value. If it was 100%, which equals the original percentage value, in that case, that means there is no change. And in the last case, we can put it as this is 100% minus 10%. And as we had discussed for fractions here, we can say any percentage which is greater than 100% is an improper percentage. Any percentage which is equal to 100% can be termed as either as cent percent, or you can say ideal percentage. A percentage which is greater than 0% but lesser than or equal to, or let's say greater than 0% but lesser than 100% will be termed as a proper percentage. Right, so now it becomes quite easy, and from here we'll be able to say that FV upon OV will be what? This will be nothing but the fractional change that we have already had into 100%. And as discussed, you can further say that it will have 3 cases here. Those 3 cases we have already discussed. And analogously, you could have said 3 cases for the fractional changes as well, which also we had talked about, which is increase, no change, or decrease. I hope this would give you greater insights about the topic, and then it will help you to take this topic to the next level. The more you practice, the better it is for you.